Hi. In this video, I'm going to go over all the things you need to know in order to write an amazing lab report for Chem 100A. And hopefully this should extend past Chem 100A and into any scientific writing you plan on doing in the future. I really hope you take this class as an opportunity to develop your writing skills um, because it's really important. But there's a lot to learn, and lab reports have a lot of components, and it's important for you to know what information should go into each section. And it might be tough at first. You're right here, and you'll be struggling to figure out how to write a really good lab report. But all of us TAs are here to help you, and by the end of it, you're going to be just amazing writing stellar reports. Okay, so first of all, general style formatting stuff. We want your lab reports to look like you're publishing them in the American Chemical Society journal. Okay, so you might want to take a look at the ACS style guide. There's also some ACS templates available, and also just browsing the ACS journal website and taking a look at some articles and seeing what's expected in a scientific journal. Just some broad things though. It's a good idea to always write using justified text. Don't indent any of your paragraphs. Everything should be single spaced, font size 12. Also, you'll want to use columns for all portions of the lab report after the abstract. Okay. In addition, all your references and citations in text and at the end should be in ACS style. So I'll talk about that later. Okay. Some grammatical stuff that you should try to perfect right now as a scientific writer. You always want to use passive voice and third person. Okay. So passive voice sounds like this. The density meter was used instead of saying that the density meter measured the density. Okay. First person is when you say I, we, any of those pronouns. So you want to just avoid that completely by writing in passive voice. So instead of saying in this experiment, we determined the density of seawater, you would say in this experiment, the density of seawater was determined. Okay, first thing that you read on a paper is the title and all the information that's at the top of the page. Okay, so the title is super important. You need it to include all the information that's pertinent to the experiment, but you don't want it to be too long at the same time. You want to stay concise. Okay, so some examples of a bad title are density and salinity experiment. Being too vague, no one would want to open that article because they have no idea what's going on. But then on the other side, you might go into too much detail, writing a super long title that bogs people down and then they're not interested. So you want to find that sweet spot in between where you give all the information. Yeah. Other things to include at the top of the page are your name, section, the date that it's submitted, and the address associated. So you'll see here as an example of formatting that would be acceptable. Has the title at the top in bold or in larger font. You have the author names, date. You should have your section number too. And the address should be italicized. And usually you'll notice in papers, you have some symbol that you put next to your name associated with the address. And if there are multiple collaborators, they would have different symbols and different addresses. So you can practice that. Okay. Next thing up in your paper is the abstract. It should be a really short summary that basically just includes three things. First, the purpose. Okay, briefly state that in a couple sentences. Next is the methods. Again, very brief, 1 to 2 sentences. What instrument or method in theory did you use? And last, you include all of your results that you obtained in that experiment. Whenever you report your results, you should always have the uncertainty associated with that value formatted like this, where you write the mean, that answer result that you found, plus or minus that uncertainty, and then put the units at the end. Okay. Here's the formatting. Generally for the abstract is to put borders on top and bottom, okay? And you'll wanna say, this is the abstract, write it in bold. And we're using the same formatting style that I mentioned before, justified, single-spaced, no indenting. Here's an example of an abstract that I wrote when I was an undergrad. So you can take a moment to pause the video and take a look at this breakdown of this abstract. Short and sweet, but has everything you need. Okay, next up is the introduction. So there are a handful of things that need to go in the introduction. You need to explain what the purpose of the experiment is. Like, why are you doing it? What's the importance? Real world applications, all that stuff. You also want to explain kind of the theory or the fundamentals behind any methods that you're using. If there are any chemical reactions being done in the experiment, they should be included in the introduction. And also any important, like unique formulas, equations that you used as a part of your methodology, those should go in the intro too. So since you will be including equations, reactions at some point in this course, here's how you should format them. In the sentence before the equation comes up, you should reference the equation. So in this example, I say, according to Beer's law, equation 1, the absorbance of the solution and its concentration are linearly related, okay? And then you have the equation. And I recommend using the equation editor in Word in order to type your equation. You want to have the equation centered, and you want to have that number associated with it referenced on the side, right justified. Okay. In the sentence right after the equation, you want to define all of the variables and their units that were used in that equation. Okay, so here I said where A is the absorbance, arbitrary units, epsilon is the molar absorptivity constant, units, etc. Okay. Also very important for the introduction is to cite your sources. Basically, if you don't know, if you're saying something that you didn't already know, you need to cite it, which is basically going to be every single sentence in these lab reports. Okay, so you need to make references to publications. Ideally, those are peer-reviewed papers. Those are textbooks. Those are lecture slides. Ideally, you would not reference websites. Okay. Where do you find papers? That's a great question. You can just go online, search for stuff. Google Scholar is a great beginning source. Also, Academic Search Complete. You can access so many papers by being a UCSD student. And since possibly and probably you are off campus, you should use the library VPN in order to make it look like you're on campus. Then you have access to everything. When you do reference something, when you type a sentence in your introduction and realize, oh, I didn't know that information, I need to cite my source. How do you do that in text citation? In ACS formatting, it's a superscript number, okay? So you type this sentence and you're like, oh, this is the first reference I've made, so I'm gonna put a superscript 1, and then later in the references section, I should be able to go to number 1 and see where that came from. Okay, note that this number 1 comes after any punctuation, not before, like in this example, okay? The references should appear in numerical order. So the first thing you cite is number 1, and then a couple sentences later you want to cite something else, that'll be number 2. You don't need to do it and shouldn't do it in alphabetical order like you may be familiar with in some other formats. You are definitely welcome to have more references on a single sentence, and you just tack them on after commas. Okay. Also, I'm going to point out this at the end of the slideshow. I'm going to talk about this really, really useful software called Mendeley, and I highly recommend you download that because it's going to make all of this reference nonsense a lot easier. Okay, formatting. This is the formatting for the rest of the paper. You're switching to columns now. I want you guys to practice using columns because a lot of papers require them, and getting them set up is kind of tricky. So here's how you do it in Word. Go layout, columns, more columns, 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 columns. Make sure you title every section that you come into, bold. You're typing single spaced, okay, and leave a space in between each paragraph. This makes it really clear, and don't indent your next paragraph. Make everything justified. Okay, next up is methods. Methods, you are telling the story of what you did in the experiment, okay? Telling a story. Be an author here, okay? You want to avoid copying the lab manual or lab protocol, and do not use bullet points. You're writing it out in paragraph format. Some important things, you're telling the story of something you did in the past, so you need to write it in past tense. You also need to stick with that, what I said earlier, passive voice in third person. Even though it's something you did, you need to explain it in passive voice. And in addition, a common mistake is students are like trying to tell the reader what to do. That's not what you're doing. You're telling your story. Okay. Some important things you want to embed into this story is the model names of and numbers of any instruments you use and their tolerance. Very important. If you have them, pictures, diagrams, sometimes useful. Big thing, sorry. Last bullet point on here, do not report any results in the methods section. None, okay, none. Here's a short example of a methods section if you want to take a look at that. This was from, again, undergrad. It's just showing how you can be concise, but also include a lot of information at the same time. Okay, next up, results and discussion section. Typically, they're written separately. Typically, you have your results section, and then you follow it up with a discussion, okay? Now, what are results? Well, you did an experiment. You were writing down your raw data into your lab notebook, but that's data, okay? Results are not the same as data. Results are what you get after working up the data, okay? So your means after doing calculations, all of those uncertainties and relative uncertainties, yeah, results of calculations and propagated errors, stuff like that, okay? We don't want to see big tables full of raw data. That's not what a lab report is for. A lab report is for reporting your results, what came from that data. Okay, so in the results section, you will probably be using tables. So here's how you should format tables. The title should always go on top, above the table, and you want to make sure that you label the title with a number. So you'll call it Table 1 or Table 5 and give it a short little description right on top. Okay. Other important things should always include units in your table. That's one thing that's lacking from this example, again, that I pulled from an old lab report that I wrote. You should have units on every one of these columns here. You will probably also be using figures. Formatting figures is basically the same, except now your title right here should go below the figure. Okay, for tables it was above, but for figures it goes below. Whenever you have a graph, you want to make sure you have a title on it. Make sure that both of your axes are labeled and that you include units. Again, units are very important. Okay. Now, the discussion section, which follows the results, should be explaining what those results mean. If there are any questions that you've been asked to answer in the lab protocol, make sure to answer those here. Some things that you should discuss in a discussion section include accuracy, precision, sources of error. Okay, so we'll talk about that. Also, it's good to talk about the instruments you used and go over the efficiency of those. So you might want to talk about their cost, how long it took, applicability to other experiments, things like that. Okay, so quick overview. Precision, a measure of how close your trial results were to each other. You're going to want to discuss, was your experiment precise? And in order to make that argument, you need to use a figure of merit to back it up. You need to use some qualitative value to back it up. So when you want to argue that your experiment has been precise, you want to use the relative standard deviation of your result to make that argument. Okay, so the formula for that is right here. It's 100 times you take the standard deviation and divide it by the mean that's associated with it. Okay, the reason why that's important, sometimes you do an experiment and you get a standard deviation that seems super small, 0.0001. And you might be tempted to just type, this experiment was super precise because that standard deviation is very small. That's qualitative, not backed up by anything particularly. Because, for example, what if the mean of your data was 0.0002? That error in relation to that result is actually huge. It's actually a 50% error. Okay, so that's why it's important to report relative standard deviation. In this case, you would be arguing, unfortunately, the precision of this experiment was poor because there was a high percent RSD. Okay, on the other hand, we have accuracy, which is a measure of how close your results were to literature values. Okay, the figure of merit you want to use to back up that argument is percent error. So if you want to say my experiment was accurate, you have to say because the percent error was low. Okay, so there's again the equation for percent error, where you're comparing your result that you got in your experiment to the theoretical or literature value. You need to cite whatever that literature value is that you're comparing to. Sometimes they're provided or discussed in lecture what that literature value should be, what that correct answer is. Other times, you should go explore, search for some papers. All of these experiments in this course are concentrations of components of seawater, so you can just go to Google, concentration of X in seawater, and I'm sure you'll find some papers. Okay, you'll also want to discuss the sources of these errors in the experiments. What we're looking for here is fundamental flaws in the procedures, in the methods, in the instruments themselves, okay? Some examples. Some of them can't really be fixed. So if you're doing a titration, which is done a couple times in this course, one source of error is the fact that this method inherently, fundamentally is measuring the endpoint, not the equivalence point, but we make the assumption that the endpoint and the equivalence point are close enough. So that would be a source of error. Fundamental, can't avoid it. Another example would be one that could potentially be improved a bit more, like matrix effects, which we'll talk about in this class plenty. So if you are experienced matrix effects, maybe you could do the experiment differently, use a different method, maybe take a calibration curve method, or method of standard additions, or some other method to fix the problem. It might be valuable, you just did an analysis of your precision and your accuracy. You can categorize those into systematic and random error, okay? Accuracy is associated with systematic error, and precision is associated with random error. So sources of error can be tied to those as well, where if you had poor accuracy, that means there was some systematic error going on. And that means your source of error would have been something that caused a bias in one direction from the true value. On the other hand, if you had low precision, it was probably the result of random errors, which is just indeterminate causes that caused your results to vary on both sides of the mean, spreading out your Gaussian curve. Okay, lastly, the conclusion section. This is kind of the main takeaways. You're summing it all up again. It's usually like a slightly more detailed repetition of the abstract. You want to restate those purposes, restate your results. You do want to add in this last thing, which is implications for the scientific community. Namely, in what type of situations could the instrument be applied to other experiments? You want a scientist to read your report and at the end be thinking, that's really interesting. I wonder if I could use that somehow. So you want to, just give a little bit of information about how this instrument vaguely could be used elsewhere. Okay, references section. Sorry, I lied. We have one more bit. References section comes right after the conclusion. You do not need to put it on a separate page. It's going to look like just a numbered list. Remember I mentioned before, the first thing you cite will be number 1, and I should scroll down and see number 1. Just a normal bullet point numbered list. Okay, again, do not alphabetize. I have a link here for reference formatting. It'll be last name, comma, first initial, period, comma, next author, last, etc. You can figure that out. But another thing I want to stress is using Mendeley because it will save your life. This is a downloadable software. It will connect you to Word and automatically create a bibliography for you, which is pretty cool. So I want to demonstrate that real quick. I'm going to open up a new document. Okay, let's say I write a sentence that says, dogs are great. But I can't just make that statement. I need to back that up somehow. I need to cite this. So after you set up Mendeley, downloaded that app, that software, which is right here, Mendeley, you will have a library. And you can just drag and drop papers right in there. And it automatically pops up all of the information. So this is one that I'm looking at for my research right now. And then you can go back to your paper here, and you go into this references tab in Word, and you click insert or edit citation. Okay, that's going to add your in-text citation to this sentence. Okay, so we'll click that. And then you can just type some keywords. So that paper I was just showing you a minute ago is this one, the author blue. select that. It takes a second to think, and oh, look at that. This is the first thing I've cited in this document, and since I'm using the American Chemical Society format, it puts a superscript 1 in there. Okay, I keep typing, blah, blah, blah. Let me add another citation to that. About this guy. Okay, and now we'll go to the end of my paper. I want to insert a references section, and then all I have to do is click insert bibliography. Clicked, and it takes a second, and voila! You didn't even have to go look up how to do ACS citations. It does them for you. You might want to double check that it did it correctly because sometimes it messes up, but yeah, that is amazing. And super cool thing, if you are ever publishing in journals and maybe your article doesn't get accepted in one journal or you decide to change journals, whatever, say first you tried for an ACS journal, but then you want to switch it up. And maybe maybe you're trying chemical education, research and practice as your new journal. It will automatically update the entire document for you. Where I used to have superscript numbers, now it shows how it should be written in this other format, and the references section is updated. Now those citations are in this new format. Okay, I'm going to put it back just for me. Back to our presentation. Yeah, so just in general, other resources, TAs, we're here to help. Office hours, it's great. That ACS style guide is like a super duper long version of this presentation, so you're welcome to delve into that if you want. If you need help with the writing, if that grammar stuff is troublesome to you, the Writing Hub is a good place on campus to go, to learn more about that. Okay, so that's it from me. Good luck in your lab report writing. You're gonna do great.